Okay, 3 forces act on a particle, so we've got particle. 3 forces, first due east, so that's P. Second has a force of 5 newtons and acts due west, 5 newtons. And the third has magnitude 2p and acts vertically upwards. Okay, so I'm going to say that is vertically upwards. I have to imagine that's sort of coming out at me from the paper or screen or whatever. And that's 2p. That's not north. Okay, that is east, that's west, but this is coming straight up. The resultant of these three forces has a magnitude of 25 newtons. Okay, calculate P. Well, I'm going to put these two together, so P and 5, and so that means I'm going to get, in essence, I'm going to have a force, that bit being P minus 5, and if I add the 2P onto it, then the resultant is 25. That bit is 25 newtons. And now I can work out what P is, because I've got a right angle triangle, and I know that if I do square root of P minus 5 squared plus 2P squared, the resultant of that is 25 squared. That's 25, so I square rooted it. Multiply this all out, that's going to give me P squared minus 10P plus 25 plus 4P squared. And also square both sides, so square the left hand side, so I get that. Square right hand side, 25 squared is 625. Tidy this all up, I got 5P squared minus 10P minus 600 equals 0. I divide through by 5, so P squared minus 2P minus 120 equals 0. If you can factorise it, it's great. If you can't factorise it, use the formula. But 120, they've got to be fairly close together, because this is a number that times that will give me 120, because the difference is only 2. So the first thing on the close numbers, or 10 and 12, that's what it is. 10 and 12, and we want the 12 to be negative because it's negative 2, and P to be and 10 to be positive. So therefore either P plus 10 equals 0, so that means P equals negative 10, you can't, or P minus 12 equals 0, so therefore P equals 12, and it can. So P does equal 12. Done the first bit, and now find, so I've worked out P, the angle between the resultant and the vertical. Okay, so resultant goes up like so, and we want the angle between that, we want this angle here. So we know that this bit here, P is 12, so that means it goes across by 7, so that goes across by 7, and we know it goes up by 2P, so that's 24. So it's 24 there. That's the angle we want. So that tells me that tan theta is opposite over adjacent. So 7 over 24. So theta equals tan to the minus 1 of 7 over 24. And so theta equals 16.26020471 degrees, or 16.3 degrees to 3 significant figures. So that does the first bit. Then we've got 7 marks for that. Calculate the mass. The particle has a mass 3 kilograms. Okay, so the particle has a mass 3 kilograms. Ooh. So it's 3 kilograms, 3g, and rests on a rough horizontal table. So that means I've got friction. I'm going to have friction going back this way. And it tells me what mu is. Mu is 0.15, so I put that in somewhere. I've got to find the acceleration, so it gives me a clue. I've got to have an acceleration. Right. So I got the 3 forces acting on this. I've also obviously got normal contact force. So I've got R, and then I've got my force, the component is 25 Newton force going up like so, and that's 25 newtons. But we actually know that that is made up of 2 components. That is made up of this component, which is 24, and this component here, which is 7 newtons. And so that will help us when we're working this bit out, hopefully. I think it's all the forces. That's our major force. That's made up of 3 things. And because the P is 12 and that's 5, it will certainly go to the east. State the direction where it moves. It moves to the east. Right, we've got acceleration. I'm going to have to, I need to know what the friction is. To know what friction is, I'm going to have to resolve to find out what R is as well, because we've got limiting friction, so F equal mu R. So I'm going to have to resolve upwards. And it's really important we say what we're doing, and that means I'm going to have the upward force equals the downward force. So that's going to be R going up plus the 24. Now you may have done 25 and then done cos of that angle, which is 16.3. You might have done that, but it's easy to note like this. And that equals 3g. And so R will equal 3g minus 24. So R equals 5.4 newtons. So I've got R. Now I can work out what F is. So I know that F lim, because it's moving, it's accelerating as well. So therefore it's going to have limiting friction equals mu R. And so F will equal mu, which is 0.15 times by 5.4, and that equals 0.81 newtons. And now, done that bit, I now need to have resolved upwards. I've used that, and I'm going to have to resolve to the right, the direction we're going to, the direction of acceleration. And here I'm always obviously going to put down resultant force equals ma. I can't say just left equals right. What have I got going to the right? Well, I've got the 7 newtons there. I've got minus the F, so it's minus 0.81 will equal my mass, which is 3 times by A. And that'll say that A equals 6.19 over 3, which equals 2.06333 meters per second squared, or 2.06. And it's going east. And that's it. And it's quite nice. This breaking this force up here is quite good. I say you could have done, if you wanted to, I'll put it in pink, that's 7. To get that one, obviously, is 25, and then it's sine of that 16.26. So I could have used it like that, but it's much quicker if you can see how it breaks down into its components. And that's 5 done.